Do you know what makes a planet? Astronomers are introducing a groundbreaking, more quantitative definition promising unprecedented clarity. This new definition focuses sharply on the object's mass, offering a precise standard, including exoplanets. Stay tuned to learn more about this proposal. And don't forget to subscribe our channel. Astronomers are once again revisiting the definition of what constitutes a planet, nearly 20 years after the International Astronomical Union redefined it, resulting in Pluto's reclassification as a dwarf planet. This new proposal aims to introduce clearer, more precise criteria to better categorize celestial bodies within our solar system and beyond. Among the key considerations are the object's mass and its ability to clear its orbit of debris, a characteristic that currently distinguishes a full-fledged planet from a dwarf planet. The proposed changes come in response to ongoing debates and discoveries in the field of astronomy. Advances in technology have allowed scientists to observe and learn more about the countless bodies in space, leading to a need for more detailed classification. The redefinition would provide a framework that can accommodate these new findings, ensuring that our understanding of planets remains up-to-date and scientifically accurate. Currently, the International Astronomical Union defines a planet as a celestial body that meets 3 specific criteria. It must orbit the Sun, be massive enough for its gravity to shape it into a nearly round form, and it must have cleared its orbit of other smaller objects, aside from moons and satellites. This definition was established in 2006 and has been the standard since. However, the current definition has been the subject of much debate within the scientific community. According to Brett Gladman, an astronomer at the University of British Columbia, the main issue has been the lack of a quantitative, measurable definition for the term planet. This gap has led to ongoing discussions and the need for a more precise classification system. To address this, Gladman and his colleagues have proposed a new definition of a planet, aiming to include more measurable criteria that can be uniformly applied. This proposal was detailed in a paper published on July 2024 in the Planetary Science Journal and is set to be presented at the International Astronomical Union General Assembly in August. The proposed changes are significant because they offer a more nuanced understanding of what constitutes a planet. By incorporating measurable characteristics, astronomers hope to create a more inclusive and scientifically robust framework. This new definition could potentially redefine how we categorize celestial bodies in our solar system and beyond, affecting both current and future discoveries. The upcoming presentation at the International Astronomical Union General Assembly will be a crucial moment for this proposal, as it will allow for a broad discussion among the global astronomical community. If accepted, this new definition could lead to a better, more accurate understanding of our cosmic neighborhood and the various objects within it, including planets, dwarf planets, and other celestial bodies. According with scientists, without a quantitative point of reference, the current definition of a planet faces several significant issues. One of the main problems is the vagueness of the criteria. It's unclear how large these celestial bodies need to be or how clear their orbits must be to qualify as planets. For example, both Earth and Jupiter have asteroids that regularly cross their paths, which raises questions about whether these planets truly have clear orbital paths as required by the definition. Furthermore, the current definition does not take into account objects that orbit stars other than the Sun, such as the more than 5,500 exoplanets that have been discovered beyond our solar system. This omission highlights a significant gap, as it excludes a vast number of celestial bodies that share many characteristics with the planets in our solar system. Proposing a new definition points out another major issue. The most problematic by far is the roundness criterion. Roundness is simply not observable. We do not have the technology, and we will not have the technology anytime soon. This statement underscores the difficulty in accurately measuring the shape of distant celestial bodies, making it challenging to determine their status based on the current definition. These shortcomings have led the astronomers to propose a more precise and practical framework for defining planets. Their proposal aims to address these ambiguities by introducing concrete, measurable criteria. This new approach could provide a clearer and more comprehensive understanding of what qualifies as a planet, potentially leading to a reclassification of celestial bodies both within our solar system and beyond. The updated definition would help astronomers better categorize the diverse range of objects they encounter, improving our understanding of the universe and its many components. To ensure that their classification framework would be logical and unbiased, the scientists employed a method called unsupervised clustering, an algorithm designed to group similar objects based on their characteristics. This technique proved effective in categorizing the 8 planets in our solar system, reinforcing its reliability. No matter how many criticisms you can lodge at the current definition, you can at least be satisfied that the outcome, the 8 planets, is the reasonable classification. This statement emphasizes that, despite the flaws in the current definition, the resulting classification of the 8 planets remains sound. The astronomers further argued that the ability to clear their orbital paths, a concept known as dynamical dominance, is directly related to a planet's mass. Only objects with a sufficiently high mass, such as the 8 recognized planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, can achieve dynamical dominance. This means that these planets have enough gravitational influence to clear their orbits of smaller debris and objects. By focusing on measurable attributes like mass, the proposed framework offers a more objective and scientifically robust approach to classifying planets. This method not only supports the current understanding of the 8 planets, but also provides a clearer, more precise definition that can be applied consistently across different celestial bodies, including those outside our solar system. This approach aims to refine our planetary classification, ensuring it remains relevant and accurate as we continue to explore and discover new objects in the universe. The concept of dynamical dominance also establishes a minimum mass requirement for classifying an object as a planet. Despite this, Pluto, which has a mass of only 2.88 times 10 to 22 pounds, 1.31 times 10 to 22 kilograms, will still not meet the criteria to be considered a planet under the new definition. This reflects the ongoing challenge of fitting Pluto into a more precise classification system. When it comes to roundness, the new definition takes into account that celestial objects with a mass greater than 10 to 21 kilograms are typically spherical due to their own gravitational pull. This is because such mass allows gravity to shape the object into a nearly round form. Thus, the new definition incorporates the roundness criterion in a way that is more feasible with current technology. The researchers behind the new proposal explain that the revised definition does not fundamentally contradict the existing definition, but rather adds greater specificity to it. The new framework refines the criteria by introducing measurable thresholds that provide clearer guidelines for what qualifies as a planet, without abandoning the principles of the current classification system. By addressing both mass and roundness with a focus on practical measurements, the updated definition aims to improve the clarity and applicability of planetary classification. This approach ensures that the classification remains consistent and scientifically sound, accommodating new discoveries and advances in our understanding of celestial bodies. Humans are deeply connected to language, names, and classification because these are the tools we use to understand and navigate the world. This is how we manage the complexity around us. We seek to name things and categorize them. Scientists share this drive. We simply aim to do it with greater precision. Despite the potential for resistance, the process of refining definitions is essential. The researchers will present the new proposal at the International Astronomical Union General Assembly in August 2024, though they do not anticipate an immediate consensus. Instead, they hope the presentation will attract interest from individuals who are eager to explore and discuss the new ideas further. It is emphasized that the proposal stems from a strong belief that the scientific community can improve its classifications. The researchers said they are driven by the conviction that we can do better as a community. This reflects a commitment to enhancing our understanding of the universe through more precise and reliable classification systems.